In today's video, we are going to learn more about how we can have an array full of object references and also how to use a for loop versus a for each loop depending upon what we are doing. All right, let's first talk about an array of object references. This is a very useful feature to have because, as we've talked about, we can have an aggregate object where an object has one of its instance variable as another object. Well, we can build on that by allowing an object to have an array as its instance variables. For example, let's say I created a variable or a class for a library. I could have in my library an array of books, and this would keep organized all of the references to all of the books that I have in my current library. This is an example of how that reference would look. Now recall that when I have this line of code right here, because I have not said equals new array, I haven't actually built the array. All I have done now is created an array of references or of pointers that are able to point to book objects. If I want to actually instantiate this array of books, I would have to add another line of code, and this would be done in my constructor because we're talking about an object with instance variables. So in my constructor, I would say, for example, book list equals new book, and then I would define the size. So what this does is this creates a reference that is ready to point to an array of book references. So it's a reference of references, so to speak. And then I am going to, in my constructor, actually set aside and allocate space for 10 book objects. So now this will go ahead and point to this array, which will point to other objects. So in memory, it would kind of look like this. We would say book list points here, and then just pretend that that's 10 references, and each of those are going to point to additional book objects. Okay. Now, one of the things that's nice about this is if we contain them all in an array, we can loop through the array using for loops, which is one of the skills we're going to talk about today. Another nice thing about this is that we can still access those methods that we have in the book class through the specific entry that we are referring to. So we would have to say find by book list array, find index 2, which is actually the third book, and then once we get to that third book, I want to call the getTitle method on this object. So if I use the name of the array, I'm essentially referring to the whole list of book objects. If I am giving a specific entry in the book list array, then I can call a specific method on that specific object. I know it's kind of confusing. One of the things that we will caution you against is using parallel arrays. Sometimes people like to use parallel arrays as an alternative to having an object. So what I mean by that, this over here is the bad side. We do not want to do this. In the bad side, we have an array for account numbers, an array for balances. We can have an array for string names. And then you would basically say that everybody in the same entry of all of those individual arrays refers to the same person or bank account or book. Well, that's really complicated because you're having to maintain multiple arrays when all of the entries in the same row are actually connected. So instead, what we want to do is we want to use this idea of an object and have the object contain all of the data. So what we would want to do is create an array of, in this case, bank accounts, and each array entry refers to a specific bank account, and then that specific bank account can organize any data necessary. Okay, so in this example on the left, we have an array of objects, and each object contains its own personal copy of the variables necessary. In this bad example on the right, we have multiple arrays all holding one data field, and that's not an organized way of doing things. Okay, next we're going to talk about how we can actually circle through these arrays using loops. So the first technique that we've already talked about that we'll revisit is the for loop. And we call this a traditional for loop. And the reason why we call it that is because we are going to learn an abbreviated for loop in just a minute. So let's say, for example, I wanted to go through this for loop and I wanted to access every single value in the array. I could go ahead and say start at the beginning, 0, go until we are less than the array length, and remember it's necessary to use less than here, not less than or equal to, because that would give us an out of bounds exception. Because the array indices start at 0 and go to length -1. And then here I'm just going to increment by 1. And then what I am going to do, notice this notation, this ARRI, what that is going to do is it is going to access every entry in this array and then add it to that sum variable. Now, there are two common mistakes that people make when working through arrays. The first I already mentioned, which is using the less than or equal to. The second is putting the open-close parentheses after length. It's easy to confuse this because with strings, we say dot length to get the length of the string. And that's because dot length is a method of the string class. In this scenario, length is a public instance variable for the array object, and that is why we can refer to it by just saying dot length. You will get an error otherwise. The second type of loop is called a for each loop, and in some sources this is also called an enhanced for loop. Now, these only work with arrays and array lists, which we'll learn about next week, and they can be very helpful. However, there are some times when they are not going to be useful. So let's talk about when they are useful and when they are not, so that we can make sure that we use them properly. So let's say I wanted to take a look at that same scenario that we just talked about. Well, in that scenario, I could use a for each loop. And here's how this works. We essentially say for, and then we have int num, and then colon array. So it's essentially going to be the data type, which in this case is int. It is going to be temp variable name, which in this case is num, and then a colon, and then the array name, which in this case is ARR. And what this notation tells the computer to do is it is going to find every int inside the array and temporarily call them num one at a time. So you'll notice that the notation is much simpler here in the code. Instead of having to say ARR bracket I can simply just say num. It's kind of like, let's say I had the whole class line up in a row and I had all of the students lined up. And even though you all are unique people and you all have your unique names, let's say somebody was coming in to talk to you each one at a time, they would say student, step forward. And this person would step forward and do something, and then they would go back. Student, step forward. They would do something and they would go back. And in each time, the person talking to you would just keep on calling you student because it's a generic word that can be used to describe all of you. Well, that's similar to what's going on here. We know that these are all integers, so we're just going to temporarily call them num. And we'll say, let me get this num and add it. Let me get the next num and add it. Let me get the next num and add it. And it's going to go all the way through. Now, one thing that you'll notice is that this has the value be a temporary storage. So if I were to make changes to num, those changes would not save. All this allows me to do is temporarily access that value in the array. Also notice that nowhere in my loop header do I use a variable. That's because for each loops start at the beginning and go to the end. There's no way for you to decide how you want them to be traversed. If you want to count by 2s or 3s, none of those options are available to you. So let's talk about our limitations. First of all, a for each loop must access all elements from the first to the last entry. If the array is partially filled, this isn't going to work for you because when you get to those later elements that don't have any data in them, you'll start having unpleasant results. You are also not able to identify the index you're currently on. With a traditional for loop, you can tell the index because of the loop control variable. Here, we don't have an LCV, so we can't access it that way. And this loop is typically used when you want to do a certain action for every entry in the array and don't care what specific entry you're currently on. So as we mentioned, if we wanted to add up every entry in the array, it doesn't matter which one we're on because we're going to add up all of them eventually. In this scenario, the temporary variable that is used is like a formal variable or a formal parameter. So what does that mean? That means that changes made to this variable will not change the actual value in the array. Now, the exception to this is if you are using a for each loop to go through an array of objects. And the reason why this is an exception is because in this scenario, the temporary variable is a copy of the object's reference. So any changes made will actually change the memory. So this is like how the example I gave in class when I said I posted a link to a Google, to a Google Doc. So if I post a link and I allow you edit rights, well, in that case, it doesn't matter how many times I copy and paste the link. Everybody who has it has edit rights. And that's like what's going on here. Even though this temporary variable is a copy, this copy is the actual address in memory, the actual editable link. And so that for each loop would be allowed to make changes. Here's an example of how a for each loop can make the code much easier to read. So let's say we were talking about social media and how we go through and log in. So this is an example of a login method. We could accept a string for the username and a string for the password. And essentially how we would read this is for every account, which we'll temporarily call next account, in the array user list, I want to check if for that account, we're going to call this method. That method username equals the username that's passed in. So if the username is a match, now I do the same thing and I call the password. If the password is a match, then I return true. If I've gone all the way through and I still haven't found it, then I return false. So this code is much simpler to read than if I were to have had a for loop, and that's why we like for each loops when they can help us. The last thing that we're going to talk about is a simple searching tactic. So the tactic we'll talk about today is called a linear or sequential search. And this is essentially when you start at the beginning of the array and keep on going one by one down the row. A simple linear search can be done with a for loop or a for each loop depending on your purpose. In this scenario, I'm going to return the index of where the element is found and -1 if it is not found. This is a common tactic used because -1 is an impossible array index, and that's how it's kind of like a universal signal that yes, it wasn't found. So here I'm starting at the first, going into the last, and I'm checking to see if the value passed in that I'm searching for is found at that current array entry. If it is found, I automatically leave the message and return that index. If I have managed to go through all of the values and just keep on circling around and I've gone through all of them and I still haven't found it, then if I get to this statement, that means I've finished the loop, the item was not there, and I want to return a -1. Now, if in this scenario I want to return the specific index, so here a for each loop would not work for me. However, sometimes we don't care about the specific index, we just care if it's found. So if that were the case and all I cared about is if it were found, then this method could be a little bit different. I could change it, and I could change it to say it's going to return a Boolean. And if it is found, it will return true. And if it's not found, it will return false. And then I would change the for header to say for each int, which we will typically call num, for each int num, the colon goes after, erase. For each int, which we'll call num, in the array, I would say if val equals num. And that's how I could modify this code. All right, so this last slide just goes through a couple scenarios when the for each loop would and would not work. So it would work when we're trying to determine if a value is in there and return true if it's found. It would work if we wanted to find the average for all scores in a completely filled array, if we wanted to print every entry in the array, or if we wanted to call a method on an object and modify its contents for every entry in the array, but it would need to be on an object. However, if I was trying to see where a value is found and return the index, that wouldn't work. If I wanted to find the average of scores of a partially filled array, that wouldn't work. If I needed to print the index, that wouldn't work. And if I wanted to add contents to a primitive, that wouldn't work.